Use the graph of f to find the given limit. When necessary, state that the limit does not exist. So let's look at the first one. The first one we are looking at, let me copy it right here so that we can look at it right next to the picture. We want to find the limit as x approaches 1 from the left. So we need to know how to read that purple part. Approach 1 from the left. Well, 1 from left. Okay? So where is 1? Well, 1 is right here, right? So if you are trying to approach 1 from the left side of the graph, somewhere over here, right? So I'll follow this line, right? I will try to get to 1 from the left side of the graph. Where am I going? Ooh, we are going to that open circle right there. So if you're trying to approach 1 from the left on this function, you are going to what a y value? You're going to 4. So the first answer is 4. This is 4. All right, let's look at this one. I'm going to copy this over here. Well, this time we are trying to approach 1 from the right. So I'll write that down. Approach, well, did I write approach? No. 1 from right. So there is 1 right here again. But this time we start somewhere on the right side and we try to get to that 1. You get really, really close to 1. Well, there's a jump right there, but then it starts back over here, and then I am going to what value? Well, still that open circle. I know there was that awkward jump right there, but the graph continued. So from 2 to 1.999, 1.8, 1.75, 1.5, as we get close to 1, it was still going to that open circle up at positive 4. So the second answer is also 4. Okay, let me erase some of this picture, okay, some of this graph. All right, what's next? And I'll get rid of these two real quick. Delete, delete. Well, look, C is asking us to find limit as x approaches 1, the general limit of f of x at x equals 1. Well, notice that this left-hand limit and the right-hand limit, these are the same. So we get to say this exists, and the answer is 4, because the answer from part A, the left-hand limit, the answer from part B, the right-hand limit, they were both 4, so the general limit has to be 4. Okay, so they're all the same. Now let's look at f of 1. They're asking for a solid circle. Okay, they're looking for the filled in circle. Or I'll write down solid circle. I like that better. Like a filled in circle at x equals 1. Not an open circle, but a filled in circle. Okay, so let's see. Where x is 1, where is the filled in circle? Well, that's an open circle, right? Well, down here is a filled in circle, that's solid circle. So at x equals 1, the function is down here at negative 1. That's the y value, right? So the function value is negative 1. Later on, we're going to talk about continuity. Okay? Notice that the function value at 1 and the limit at 1 are different, right? These two are different values. Therefore, this function is not continuous at x equals 1. If the function value and the limit are the same at that given x value, then we get to say the function is continuous. But that's for later topic, okay? Right now, we're just reading this graph. But whenever I ask you to define a function value, find the function value at a certain value, you're looking for a solid circle. Okay, you're looking for a filled-in circle. Okay, just put this here. All right, next set. You're looking for the limit as x approaches 2 from the left. This is approaching 2 from the left. 2 from left. Let's see. So they want 2, right? So here is 2. And if I'm trying to go to 2 from the left side of the graph, I am going to this point right there, which is 5. So the left-hand limit is 5 because the left side of the graph, as you get closer and closer to 2, is going to 5 on the y-axis. So write down 5 as the answer for E. Now let's look at F. What if it is approaching 2 from right? Okay, so let's see. We're looking at the graph on the right side of 2 and trying to get to 2 this time. So right side of 2, we're trying to get to 2 this time. We actually end up right here. That's the point this time. So the orange graph, you see, the graph that is to the right side of 2 is trying to go to the y value of 2 this time. So the right-hand limit as x approaches 2 is 2. Oh no, look at this. Notice this time, the left-hand limit was 5. The right-hand limit, which was 2, they're not the same. So the general limit as x approaches 2 does not exist because 5 does not equal to 2. Okay, the general limit does not exist because the left-hand limit does not equal to right-hand limit at x equals 2. Okay, all right, let's find the function value at f at 2. Where is the solid circle? Where is this filled-in circle at x equals 2? That's what this is asking. So let's go find it at x equals 2. Oh no, is there any filled-in circle? Oh yes, there is. Right there at 2, 5. Right? So the function value is up at 5. Not down at 2. This guy is an open circle. The function value is at 5. Okay, because we have a solid circle at 2, 5. All right, we're done with the second set. Let's go with the third set on the bottom row. So this one right here is asking us to find the limit as x approaches 5 from left. Okay, so let me go ahead and erase some colors right here. So where's the 5 that we're interested in? Here is 5. So from the left side of 5, he's going that way first. Why not there at 5? So pick up over here and try to go to 5. Where are we trying to go? As we get really close to 5 from the left side. The y value is 2. So the left-hand limit is 2. Okay. Now what about the right-hand limit? What's this going to be? You're trying to approach 5 from right this time. So we pick up on the graph on the right side of 5, which is this piece right there. It's going down and it's going to this point, the same point right here. So they have the same left and the right hand limit. Both the left side and the right side is trying to approach this open circle at 5 too. So guess what? We get to say that the general limit, when they're asking for the general limit as x approaches 5, it exists, and that is equal to 2. Okay? When the left-hand side limit and the right-hand side limit, they are the same, we say that the general limit exists, and all of them are the same value. Now, what about the function value at x equals 5, right? Where is a solid circle at when x is equal to 5? Let's go find it. Look at that, we got a problem. Do we have a solid circle at x equals 5? We don't have one. We only have an open circle. This function is not defined at x equals 5. So what we have to say is that this is undefined. Okay? So, even though the limit existed, okay, the limit exists at x equals 5, the function is not defined at x equals 5. So later on, when we talk about continuity, we're going to say this function is not continuous at x equals 5, okay? But that is a one set of practice problems on reading limits graphically.